Welcome everybody, as I am trying to get myself sorted out here. My name is James Cousins. We're excited to have you, oopsies. We're excited to have you at today's deep dive webinar. It's all about Predict. For those that are unfamiliar, we've very recently held a construct focused bootcamp series. And that was all about helping users either get up to speed for the first time or continue to learn more and to get even better at using the product. This is the parallel. So this focuses on the product Predict, and I'll be walking you through the whole series, starting today with the first level, the beginner basic training. So I'm the analyst manager here at Rapid Insight, and happy to have you. Just as a bit of context as well, if you were entirely unfamiliar with the whole setup here, there is a second and a third installment that will be happening this time each week. So 1 week from now, the next, and so forth. You can register for those at the URL below. But time to focus on today's. We really encourage questions. We like that our relationship with all of our users is very interactive and that we get to hear from you. The webinar is not an exception. We would love to hear your questions. You can find those in the GoToWebinar toolbar off on the right side. Feel free even to toss in a question just as a test. Send something in, get in the habit. We're going to be trying to engage with you throughout today's presentation. We've also tried to make it interactive by making these slides available to you. So if our pre-webinar rehearsal serves any purpose, they should have just gone through as a handout. And my dog Greta is dinging the bell to signify that that did probably go through. I, as a personal habit, like to include the session description just in case later on you're looking at these slides outside of context, but hopefully this session description is what you were looking for. We're gonna get into it here. I'm gonna share a little bit about Predict and then get right into the fundamental functionality of Predict. So let's just jump right in. And actually, I should probably introduce, we didn't rehearse this, so this will be entertaining, but John McMillan, my colleague, is with me and he's fielding questions. John, I don't know if you want to say hi or not.
Hey everyone, happy to be here with all of you and with you as well, James. Less so, but yeah, any questions that you have, I'm going to be fielding those in the background and probably jumping in from time to time to ask some clarifying questions as we go through.
Yeah, and it's a treat to have him on board with this as well, because we're hoping to have several of those come through. So as mentioned, jumping into it here, Predict, the software, especially to anyone who's new to it, it focuses on a lot of the same principles as Construct, and in fact, as all of our software. It's meant to make it more accessible to make use of the data that you can possibly be using to help your organization or your institution succeed. In the case of Predict specifically, it makes building predictive models and performing statistical exploration a lot easier than most people assume that it has to be. So you're going to see all about that for yourself, but suffice to say that it is a statistical exploration tool, a model building tool that anybody can use or learn to use. So I have what I hope is a very explanatory, very effectively instructional set of slides available to you all. They've been made in the handout there. My goal was not necessarily to walk through a set of slides, though. I wanted to actually cover this inside of the product. So that's what I'm going to be doing. But for anyone listening here, do make a note that all of the topics I'm covering, if it's opening a data set, building connections, variable statistics, visualizing data, it's all listed in this slide deck with some helpful tips and tricks as we go through. So with that, I'm going to make the switch over to via Predict. So inside of Predict, it's a very straightforward interface at the start of things. So just focusing on people who really are new to the software and taking things slowly at the start of it, you'll notice that most of the interactivity is located here towards the top left. And I forgot to do this at the start, but I'm gonna change my resolution very quickly so that everyone can see it even more clearly. I will ask a question in the meantime to the audience. What would you describe as your level of familiarity with the software? And you can answer however you like, if it's a 1 to 10 scale, 1 being very new, 10 being an expert, or even if you just want to describe some of the specific challenges you have, that might help me manage to change the resolution here long enough to hear from you a little bit. All right. So I've done that. You should be seeing things a little bit more clearly now, but just to check in with John, any comments there from the folks in the attendance?
Yeah, it seems like we have a pretty wide array. Some people going outside of your scale to a -1, others up to a 7 or so, it looks like. So quite a bit of variability there in the audience.
I did think that panelists were not allowed to answer, but I guess, John, if you put in -1, then there's stuff for you to learn here today too.
It's supposed to be anonymous.
So the first step inside of your Predict is at the top left here, typically to open a file. Some things to know right off the bat. The few limitations on data sets here in Predict, in fact, the only limitation that I'm aware of is that it does need to be a single file that contains all of the data you hope to explore. So if you have multiple years of data, I was just on a call with someone earlier, it's always helpful to put all of those multiple years of data into a single file so that you can start to open it. Once you're down this course of action, though, it's pretty straightforward. You'll see a list of potential file types. These are all flat files. So if you have an Excel file or a CSV file or even some other sources, you can find those here. In almost every case, it's either a text or an Excel file. And once you've chosen one of those files, you can go ahead and search for it on your computer or on your network. As a quick note, I did mean for everyone to be able to follow along if they would like. So I'm going to take a little bit of extra time to explain that if you do, all of you in the audience, if you go ahead and click text files, and then if you navigate to a particular location, there is a sample data set available to you at C Program Data Rapid Insight Inc. via Predict and then samples. Now, I'm going to try and do a couple of things here. I'm going to copy and paste and then chat that out to everybody if that hasn't already been done. So that should be the file path. This is installed with the software. So this is not something that you needed to download or that you should be looking for inside of an email. It's just available to you if you have the software installed. So I'll chat that one more time before I move on. I think I'll do that. There we go. But that should get everybody up to speed, and you should be able to see some of the same relationships that I'm about to walk through. Note that if it is an Excel file, it's similar. This is more for future references. If you have an Excel file, you may find that you also need to connect to a specific worksheet just because of the way that Excel files are stored. So with that having been done, I am just going to completely intentionally close Predict and then reopen it. Not sure what happened there. With that having been done, we're ready to go ahead and open up that modeling data set file. So if I open that, and then at this point, you have some options, but for the beginner level, it suffices to say okay, and then it will pull that data set up in this very different looking interface. A quick note, because it's down here, it was something we would build that you can make connections. If you ever want to work with a database resource, you can build a connection to Oracle, to MySQL, SQL, Amazon Redshift, all of these, if you have a table located there. The only reason it's slightly different is because credentials are obviously required to establish permission. So that's available to everyone also. So now on to the actual data set. Getting comfortable with this interface, I would say that the most important thing to know is that these features that you're seeing along the top left here, all of these green tabs, these are resources. These aren't necessary steps. So if you want to visualize your data, you can use that feature. If you want to build a model, you can use that feature. But these are, what's the word? A la carte. So as you need these features, you just go to whichever one you need or whichever one addresses your questions, and you're good to go. Each of these tabs has a unique interface. So if you're in the statistics tab, you'll see something like this. And if you're in the visualize tab, you'll see this interface. So that's the basic navigation process here. Going in order, which is not necessary, but helps me to stay on track with what was in the session description there. Variable statistics for a lot of people is a really effective resource because it helps you to familiarize yourself with the data set, perhaps at a level that you haven't previously had to. A lot of times we're in the position of knowing, as an example, if you use a student information system, you know that registration codes are stored in a particular column, or you know that demographic fields are stored in a particular column, but you may not know, for instance, how many distinct values there are. So now I know about this data set that I have 59 individual departments represented. So that's the number of distinct fields column, which helps me to investigate some of my more categorical fields. There is a lot on screen, so something else to keep in mind. This is a common, I think, a commonly requested clarification is that this list on the left that you're seeing, this represents all of the columns inside of your entire data set. So if you ever wanted to take a more targeted look at just a couple of the columns in your data set, you can always hit this hide all button. And you'll see that it's gone blank. It's not removed them from the data set, it's just not displaying them. So now if I want to look at department code, I can choose that particular field. And we find this to be really helpful because realistically, a lot of people are usually working with more than 21 characteristics, 21 variables in their data set. So if you find yourself working with 100 or 200, you should definitely consider reviewing just the things that you need to. Just to pause there, I do want to keep this focused more towards common needs for our users. So there's a lot of information listed here that realistically speaking, you probably won't need to investigate or that you won't need to double check, but there are some things that we do always recommend. So inevitably, when you pull a data set into the software, you are curious about some key outcome that in this case is enrollment. In fact, this entire data set, I haven't mentioned just yet, is an admissions data set. So for higher education, it has a list of people who were admitted to enroll at a college and either did or did not. That enrollment rate in cases like this is something that you probably want to check the mean of, because this 0.42 communicates that this data set is demonstrating a 42% yield rate for admits choosing to enroll. A lot of times you may take issue with that. If you know that that's way too high, then there's something that you may need to investigate in your data set. If it's way too low, I think we all wish that that was a low number for yield, then also something you would want to investigate. For the present purposes, the one other very common need for the variable statistics pane that I would like to mention at the very least is the missing field. So if you have a critical piece of information, perhaps you're doing an investigation to see whether or not your school can comfortably switch to a test optional policy, or maybe you want to see historically what the significance of test optional test scores was. Well, you might want to double check for your test scores if there are any missing values. And 166 is not unreasonable. Perhaps these are international admits that didn't submit particularly an SAT score. So this might be something you're comfortable with, whereas something like this, the department code missing for just a little under 40% of the records, that might be more concerning. So that's another piece of information you might check here. And we'll touch back on this in the later sessions, but you'll also see things like the variable type and mins and maxes. So I want to pause there, mention again that we're happy to answer any questions that you have, but also let you know that I am about to move on towards the visualize data tab. So I'm just going to take a peek here. Cool. All right, so I'll move on to visualize. Now, as best practice, something that I would recommend to people is to bounce between these tabs, not to get too hung up on trying to answer every question you have all in one go and then move on to the next thing. It's frequently the case that you might visualize some relationship in your data and then after the fact want to double check the statistics behind it. So these really do play with one another quite frequently, and best practice is to use them as needed. But in order to visualize data, let's go ahead and queue up. So you'll see our Y variable for anyone unfamiliar, and it's highlighted in blue for anyone who didn't catch where I clicked. I'll do that one more time here. Your Y variable, typically, it's also referred to as an outcome variable or a dependent variable. This is the thing that you want to predict. So in some cases, it's retention, trying to figure out if a student is going to succeed at your school or not. In other cases, it's an alumni giving a gift or any person giving a gift to a nonprofit organization. Today, like I said, we're focusing on whether or not a student will choose to enroll at an institution. You can see this as a parallel for any other binary. However, enrollment is just something that is a 1-0. It occurs or it doesn't occur. You can also pick any other field that is binary or continuous. So choosing that, getting on to the actual visual aspect of this. Once you've chosen a Y variable, either through that option at the top or by choosing it in this list, you can then very quickly pull up a graph that demonstrates other variables' relationship to that variable. So maybe I'm curious about athletic status and how that impacts enrollment. And what we find on the support team in general of most users is that just a quick pointer on how to interpret these charts is sometimes a good place to start. So I've chosen enrollment as my Y-axis, which is showing up here on the left, and I've chosen athlete on my X-axis, which is showing up here horizontally. As a result, because athlete is a categorical field, it's a yes or no field, you're seeing that it displays one section for non-athletes and one section for athletes. And the height of the bar corresponds to their enrollment rate, or in other cases, their retention rate or their gift giving rate. But in this case, it's telling me that athletes, the ones, have a higher enrollment rate. And there are a couple of things we can do to make it clearer just how much higher that enrollment rate is. The first is I can mouse over and I see a tooltip. It's telling me that this is the group of athletes. Their enrollment mean is 65.74%. There are 108 of them in this data set, and that represents 1.8% of my overall population, the record percentage 1.83%. So there's a lot of information you can gain there, but frequently people are interested in having that a little bit more obvious at a glance. So there's this visualization options on the left that's available to you. I would bet $1 that there are even some relatively seasoned users who probably haven't made extensive use of this feature, but you can do a lot of things to make this a little bit more intelligible at a glance, or reportable for things like meetings or sharing your findings. You can change the title, enrollment by athletic status. These are sometimes simple things, but other times they really do make a significant difference, like showing the values so that they're always available to me every time I switch between this variable and others. I will say that the primary value of the visualize feature is that it's much more convenient to pull up a graph or a visual representation of these relationships just by clicking a new field, as opposed to creating an individualized graph every time you have a new question. So maybe the question now is relating to department codes. Admittedly, a more varied descriptor of the population, but it is easy for me to tell now and to see which majors, which departments have higher and which have lower enrollment rates. Keeping this in the practical realm, trying to, now that I've shown you how to come about this view, talking about what it can mean for you and how it can help you make actionable use of your data, there's a very convenient feature here in the top, this sort of sub toolbar that you're seeing here. And this button is the show related variables button. So at a specified level of significance, p-value, you can check this box and it's going to, instead of showing you all 21 variables in this list, and instead of just showing you these rates descriptively, it will actually test and then display which are statistically significant. So you should see, especially if you're following along here, that the list it has no scroll bar. It's a smaller list. This is a subset of just those significant fields in our data set. Also, for categorical fields in particular, you're seeing that there is a handful of these departments that are being identified as having statistically significant relationships, whereas others do not. And the upshot here, especially as it relates to communicating, across your teams and across your departments on whatever organization or institution you represent, this means that even though it does seem like, as an example, nursing maybe has a higher than average enrollment rate, it's not statistically significant. So at this point, it's anecdotal, whereas there are some departments that have tried and true impacts on enrollment. And actually, let me bounce over here to show you how you can show the sample mean. I've been talking about how these are higher or lower than average. And actually, if I check this button here, show sample mean, it'll add this horizontal line that represents the average enrollment rate. And we had already talked about that a little bit, but it's 42%, which again, something you might then want to discover through the variable statistics pane. So back to visualize here. I'm just going to pause again, just check for any questions that may have come in.
Yeah, we have a couple questions.
Oh, great.
So you touched on this briefly here, but as a specific example, it looks like chemistry, maybe, and then I don't know what the CMN department is, but they have very similar enrollment rates, but one is significant and one is not, and why that is the case. And I'll ask the second question once you cover that. Well,
I thought blue pen would be a little bit less of a poor choice, but I'm being proven wrong. That's a great question, and it's something that often gets asked. So let me clear, there we go. And what it boils down to is that statistical significance, especially for anyone who's newer to statistics, which really is a group that we designed the software, and we kept that group in mind. So statistical significance is requires not just a difference in averages or difference in means, which you're seeing here. 32 is different than 42, but that difference also has to play out over enough records for there to be evidence that this is not something that just randomly happened, but instead this happened enough and is unlikely to have happened more than, as it turns out, 5% of the time. So in this case, you're seeing that there are 43 records in the chemistry department, and if we look over at the communications department, there are 180 records. It's not necessarily a huge difference in the record count, but that explains why this is a difference that is statistically significant. It's likely to occur again in an upcoming population, and this is not necessarily. There's not confidence that this is going to happen every time you explore a population of chemistry majors. So hopefully that answers the question. As you get further into the statistics, there are sometimes different ways of communicating it and different ways of interpreting it. So we're happy to take that up in a more personal session, or even I can try explaining it another way.
And the second question that we have here is, what is and actually maybe we'll fold, we just got another question. I'll fold these together here. How many years of data do you recommend using, and what is a reasonable p-value?
That both are, I guess, when talking about statistics, I unfortunately have to answer somewhat like a statistician. It depends. And the thing that it depends on is that if 1 year of your data contains 5,927 admits, as one example, then you definitely can make do with 1 year of data. If, however, maybe you represent a smaller organization or institution, you find yourself maybe with just 300 records or something like that per cohort or per year, you may find yourself getting better results if you combine 2 or 3 years of data at least. So I would say it's always worth exploring what the data can tell you, regardless of how many records you have. We've had people pull up the software, add in 300 records, and still learn something about their data. But we would encourage people to aim for something much closer to maybe 1,000 or more, just because it makes for a more, I don't know, there's more to learn when there's more evidence to support the questions you're asking. The other question that you asked was years of data and p-value. Apologies, lost track of my thoughts there. The p-value 0.05 is widely recognized as a good threshold. In academic circles, there's debates over what p-value actually can be used as reliable. So you can drill down if you have more data, especially you might want to drill down to 0.01 or a lower level just to ensure that the findings are more stringent. I would also suggest, though, that as long as it's at least this significant, if the goal is to learn things that you can use in order to drive results and to make better choices, 0.05 is, in our experience, a very reasonable p-value to use. I will also say I've never used the 0.1 level. That's maybe where you're waving hands a little too much in some cases.
And I don't. This one just came in as well. That kind of follows up on that. Do you mind just quickly explaining sort of what the p-value represents?
Sure. Yeah, and it is relatively easy to summarize. Essentially, it's how often is this thing that happened likely to have happened? So if somebody hits a bullseye out of the blue, then that's not, that can happen randomly. It's unlikely, but it can happen. If, for instance, instead you see that there is a group of 200 admits, 5% of your population that is enrolling at a 10% lower rate, that's unlikely to occur that many times, and specifically it's likely to occur less than 0.055% of the time. If you were to use instead 0.01, then now you're describing things that are likely to occur randomly less than 1% of the time. So the lower this p-value gets, the less likely this observed outcome is to occur randomly. Hopefully that explains it. I made a bold claim by saying it was easy to summarize. I think if there are, I will say if there are any other questions, then I'd maybe like to field them as a revisitation of this feature, because I want to make sure that I'm able to cover some of the basics of modeling well enough. I should, however, point out what this view looks like for continuous fields. And a great example might be something like a high school GPA or a distance from campus, or maybe a days between application and term start. And so actually something that's happening here, admittedly this is a known thing about this data set, there's a strange relationship. So typically you'd be expecting to see something maybe a little bit more like this, where, and actually if I go ahead and drop that sample mean, you're trying to find some pattern that seems to have an approximate straight line going through it. There's a negative relationship. As SAT math increases, enrollment rates decrease. So people with a lower SAT score have higher likelihoods of choosing whatever school it is they're admitted to, and vice versa. However, something is happening with this relationship. There appears to be a negative relationship here, and there also appears to be a negative relationship here. And this is a great opportunity for me to talk about filtering and creating new data fields, but I'm curious of the audience, if you answer in the question box, does anybody have any thought of what might have been going on here? And I'll pause there. And actually, I guess I should mention to John that I'll need him to let me know if there are any responses coming in.
Yeah, we are getting a couple. We'll give it a little bit more time here. I will say this is something that I've run into myself when building out a data set. So this would be generally a mistake that you might make on the data preparation side.
Yeah, it's true. And this is, I think that this is touching more on the, I don't know, strategic side of how to use the tool here. But something like this is really a great example of what the product is good at unearthing, is that you have something that should be very useful to you in terms of understanding enrollment patterns, but something is happening that makes it more confusing than it needs to be. So looking at a pattern like this and trying to reason through how to fix it or how to improve it or explain it is a very common experience with Predict.
And we do have a couple answers that are right on the edge of what we're experiencing here. A couple others that are things that I didn't even think about that are great answers as well. One being possibly deferred enrollment. So that being a good example of something that could be causing this and warrant further investigation. A couple other people mentioning application deadlines. So specific cutoffs for applications, which is kind of what's happening here, but I'll let James explain.
Yeah, and it is a little bit of, obviously it's a little bit meta for the people who understand the data set and how it got introduced into the software to share this, so it's an unfair advantage to be sure. But the way that days between is calculated in any case is always, it's one variable point, so an application submission in this case, and then the term start. So as it turns out, this data set represents 2 years of data, but in the process of creating this data set, someone like myself, perhaps myself, but probably not myself, must have calculated the days relative to just one of the term starts, so that last year's data appears to, the students appear to have been applying 660 days. And so if we just basically divide out 1 year, that's probably why these relationships look so similar. So there's an easy way to fix this. And because everybody's been through because people have access to the Construct Bootcamp, you can get a sense of how to construct more intricate formulas like the one I'm about to do. But in this case, my hypothesis is that if I take the days between the app and term start and use just a couple of tricks, like in this case, the modulus operator, to divide that number of days between the app and term start by 365. It's probably doesn't look super familiar, but it's all that it's doing here. And you can always see whenever you're creating a variable, a list of functions and operators listed in this screen. And in this case, I'm using the percent operator. If I click it, it gives me a little description, but what this is going to do is it's going to return the number of days minus 1 year increments. So this is the new days between app and term start. For anyone who's trying to type this in and follow along with the presentation, that is just a percent sign 365. So if I create this, in general, like I said, keeping this focused on people who are newer to the software, you can create any new variable, sums, you can concatenate 2 strings if you want to take something that was like a college as well as a major, you could parse those out as well. That's all possible through here using any one of these functions, or sometimes these bins. Maybe you have a whole bunch of departments, as an example, that you want to categorize under the college to which they pertain, the College of Physical Sciences, the College of Arts and Humanities. So you can grab a bunch of these, and then you could group them all as I was just mentioning, the College of Arts and Humanities. So just a little bit of a teaser on how to do that. For now, talking a little bit more about how to filter on the other side of things, you'll also notice towards the top right of the screen here in Predict that the filter button supports any subdivision of your data that you need. So to give you a thought, some common needs are grouping in-state versus out of state. Maybe you would like to build 2 different models. You may also have different application types. So maybe you have early decision applicants, maybe you have early action applicants as opposed to the regular applicant population. And then in other cases, you might have even things that are more specific to your own institution or organization. So to implement any of those filters, you would only need to find the thing that you hope to filter. I'll go with in-state because it's pretty relatable. And then we recommend that you use the Get Values button that's off to the right here. It's this multicolored feature. And if I click on it, what it does is return to me all of the values that are in the data set. I can choose the one to indicate in-state students, and I can add that filter. So a lot of options available to you here in the filter, almost all of which doing a very effective job of supporting model building. And that's the next point here. And thank you, Greta. I have a timer here and also a list of things that I'm meant to be covering. So the next thing on the list is building predictive models. We've already set the Y variable, but I want to reiterate that when you're trying to predict an outcome, if you don't see what you were hoping to predict, it's always worth double checking in the statistics pane over here that it is stored as a binary or a continuous field. As long as it's one of those two, you should be able to choose it as a Y variable and then to go ahead and build your predictive models. Another quick piece of advice, I think at the same level of importance as choosing your Y variable, is that we always recommend people consider starting by building automatically. And once I click it, it performs the whole process very quickly. So I'll explain what it does first, and then I'll show you. In short, the list of variables you're seeing over here are, for the most part, all of the variables in your data set that are being found as statistically significant with respect to your outcome. When you build automatically, it's going to look through all of those variables that are candidates, and then it's going to include the ones that it finds to be the best predictors through, for the record, regression process. So it's ordinary least squares regression or binary logistic regression, but you don't need to choose because it recognizes the suitable process based on your Y variable. Apologies if that threw anybody or if that was just me tuning, geeking out. Now that I build automatically though, like I said, it moves very quickly, but what it's done is it's included the variables that it found to be the most effective predictors of your outcome, which is enrollment. And then it displays to you all of the associated readouts and metrics on this bottom left corner. There are a lot of things to look at, and I plan to cover most of them more in depth as future sessions are delivered. I think the beginner level and the functional level, the most important piece to understand is that when you mouse over any of these variables, it will present you with this tooltip. Something that we emphasize is that your subject matter expertise and the capacity to have a conversation with people in-house that understand your data, that understand your business, your outcomes, your school, that's really a lot of times more valuable than a very conventional statistical investigation, because you can say, as an example, that yes, it makes sense that our administration or our business administration majors, you can see there the one on the right side, they have a higher enrollment rate. You are probably aware of whether or not you offer a competitive version of a program, or if your version of a program is not as competitive as your peers. In this case, administration is a draw. It increases enrollment likelihood. On the other hand, high school percentile, if we're looking at this, it's cubed it, so I'll cover that in a moment, but as you can see, towards the right side, as high school percentile increases, the enrollment rate decreases. So that's how you would typically read this little illustration. And even though that's undesirable for most schools, that unfortunately is frequently the case, because students with higher academic quality can choose from a wider range of schools that they've been admitted to, less likely to enroll at any particular one. So using this subject matter expertise, you can remove fields, and then you can try to rebuild the model. However, if you rebuild automatically, this is, again, something that I like to let people know as they're starting the process of building models. It will always add back in the best available predictors, and their only way to make it not available to the process is to go to this AutoMine tab to find those fields like test scores, and then right-click on them to exclude them. Taking just a very quick step back though, this list that you're seeing, the significance is that anything in green is related to your outcome and is available for the modeling process. Anything in red is unrelated to your outcome and is not available to the modeling process. So that said, I will go ahead and exclude this. For those who recall, the last version of the model included SAT math, but if I build automatically this time, instead it's going to use apparently high school percentile and a web application flag. Now, instead of letting myself get carried away with some of the more technical aspects of this, people, especially power users, people who are familiar with statistics and can do this, any number of different ways. The typical draw, the strong advantage of this application is that you can memorize this model. So this is our in-state predictive model. And then very easily, if I hit memorize, it's going to index that. It's now stored as a model that I can reference. I can go ahead and change that filter. I could quickly double click on this condition that I've set up, change it to a 0, add in that new filter. So now I'm looking at out of state population, and I can build automatically and end up with a model tailored to an entirely different subgroup of my population. And you can memorize as many of these models as you want. And we're going to cover how to pick from between different models that you build, or how to know when to split up your modeling population in later sessions. For now, we just like to make sure that if you're doing work, you don't lose that work, that you can save it. This is about the time when I'm set to cover how to score new records with your models, but I do want to pause and make sure I'm not missing any questions that have come in.
There's one question, but I think we'll save that for the end. So yeah, we're getting close to the end here. So if you do have questions, now would be the time to submit those.
Yeah, seconded. And I'll, inspired by that, I will make sure to go ahead and walk through the scoring process relatively quickly here. This model has been memorized, which means that within the scope of this analysis, this open, you can think of it as a workbook, it is saved as an equation, a model that we can use. There are a couple of options that we have in order to save the work that we've done. The first is to export this as an equation for use in the scoring process or inside of Construct. So if I click on this blue floppy disk icon, you can see here that I have it's typical, file browser. Oh, but I'll move a folder here. And so if I were to save this somewhere, I can save this as my in-state model. And I could do the same for all of these. However, I can also go ahead and mention saving the analysis. So if I'm not ready to score with my data, with my model, but I do want to save my work and pick it up tomorrow, for instance, I can save this analysis, and I can call this anything that I particularly want. This is a Vera Predict analysis file here. So I'm going to go ahead and call it my enrollment modeling file analysis. And if I save that, I'll point out right now the significance of that is that when I open the software the next time, I can see here that the enrollment modeling file analysis I was working on is available to me. I don't have to start from scratch by opening a file. I can double click, I can open this, and I can even pick right back up exploring the models that I've built. So that's the first thing worth pointing out. The next is how to actually score new records. And that's typically through two processes. This first, that exists entirely within Predict, is the ability to score a file. And you'll be presented with something similar to opening a file. You point to the file you'd like to score, like this modeling data set that we've been using. And then if you hit OK, it will pull you into this new interface. You now have the option to either load a scoring model if you've saved it somewhere out to your network, or to select the memorized model if you have an analysis open at the given point in time. So if I select a memorized model, it gives me this list. These should look familiar. These are the two that we've just built. And so if I choose the in-state model, it does a couple of things on my behalf. It imports the equation. This is what it was building behind the scenes when we were walking through the visual layer of things. And it also notifies me that it's finding all of the fields it needs. So now if I were to start scoring, there are a couple of other options here that I'd be happy to answer or field in further questions. But if I start scoring, this is the basic process. Is now it outputs potentially a CSV file that contains all of my records and their characteristics, my students and their data, as well as a score representing their likelihood to enroll. So I can save that. I'll go ahead and save it. I can have a whole heap of files in my folders now. I will say that the maybe more conventional way, when people have both predict and construct, it's very convenient to be able to open up construct, which should look familiar, and to look at a new admit file and then simply to right click and then to use the wizard to import that scoring model. So I'll pause here. But when you import that scoring model, it allows you to reach out to any of the saved scoring models that you might have created. So if I go to my work stuff folder, this in-state model that I've just created is available to me, and it'll do all of the work of importing that on my behalf. But that's the scoring process. Keeping things at the high level, I'm happy to talk about more, but there's plenty of time in the series, and fortunately, there's also enough time for questions. So that's the gist of it. That's the basics. I guess over talking is definitely one of my stronger suits. I would like to make sure that everybody feels completely comfortable with the process. So just to recap in hopefully 30 seconds, typical process of using Predict is opening a file, which you can do by pointing to wherever that file exists, which we've talked about. Once you're inside of the interface, you can answer questions, you can figure out if there are missing variables, what's your average outcome rate, and of course you can, if you want, go straight into building your model. You do that by choosing any outcome of interest. Then when you build automatically, it will present to you what it finds as the best model. You have control over that. You can remove things manually or you can exclude them. And of course, if you have any questions about what you're seeing inside of the data set, you can visualize those to get a better understanding of exactly what's going on. So going back to maybe distance from campus as an example. So with that quick recap, I will not literally step back, I'm sitting down, but I will figuratively step back and ask John if there are any questions.
Yeah, so there are a couple questions coming in. There are a couple about sort of the accuracy of the model, and I think that is something that James plans on discussing in a little bit more detail during the next session. A little foreshadowing there. I don't know if that's actually correct. But then a specific question about what the scores look like. Is it 0 to 1 range, what that actually, the output there looks like?
sorry, I muted myself. Yeah, so since I saved that in statemodel.csv, these were my scores. You can see here a lot of these fields being familiar: SAT Math, Legacy, Athlete, FAFSA filed. Of course, this would be your data, but this final column, this is what was created. So if I zoom in a little bit and then scroll up, you can see the predicted Y. Predicted, in this case, it was enrollment. So you could, of course, relabel that if you'd like. And you can see 50%, 0.5 represents 50%. A 1 would be a 100%, whereas 0.35 is a 35%. If you're doing that in construct, what that would look like, you would just have that capacity to start to aggregate them or do other things that John showed off in his series. So if I view data, looks, of course, very similar. So PITM, FAFSA, athlete status, and over here, probability. So that's what those scores look like. I know, just worth mentioning for anyone who is newer to the process that frequently people will bin them. They'll create sort of like a highest, middle, lowest, like a red, light, green, red, yellow, green approach, or buckets based off of probabilities, but you have a lot of flexibility there.
Yeah, and maybe as a teaser for the next session, do you mind just pointing to where you identify the accuracy of the model in Predict?
Absolutely. Sorry, correction. No, I don't mind. I should mention as I do this that if anybody has questions that relate to deeper aspects of what I maybe didn't cover completely here, I would love to make a little stage note to add that into the follow-up presentations if they aren't already. But the easiest way to tell the accuracy of a model, the most intuitive, I think, is the percent concordant if you're investigating binary logistics. So if your model was based off of a binary outcome, the percent concordant, this 69.6 is effectively communicating that about that much of the time, it was accurate in determining who was more likely to enroll. There's more that goes into the process. That is something that I will probably cover, or at the very least document in follow-up slides. But another way that you can investigate this is, well, maybe I'll leave that. There is an even cooler way that is even more compelling from the business standpoint to share the accuracy of the model, and that's something that I will definitely cover.
Perfect. And then we have another question about some form of specific modeling, but a user that's looking to predict enrollment, but potentially exclude all scholarship awards, and then build a separate model including all scholarship awards. How would you go about doing that in the software here?
Yeah, and I don't, do I have scholarship? I don't think I have scholarship in this model, but hopefully a very effective parallel is that you might wonder about a version of a model that does include SAT scores and does not include SAT scores. So your couple of options are, you could create one model by filtering for people who did receive scholarship and who did not receive scholarship. So you could actually build two models for two different groups, or you could build two models for the same group. And the way that you would do that potentially is to build a model. This included SAT, of course, and it happens to have entered the model. So I'll save this as my SAT included model. And then I can compare that against separately if I exclude these fields, or for that matter, any other field that I'm curious about, if it's financial aid or otherwise. I can rebuild automatically. It's then going to try its best to create, again, the best model that it can, and I can save this as the SAT omitted model. And what's great is that there are all sorts of ways that you can compare these two models. That is definitely a focus in the follow-up of this session.
And I think those are all of our questions, and we're just a minute over time here. So we did pretty well with the timing.
Makes sense to me. Well, let me bounce back to the PowerPoint then very, very quickly, just to pull and blow by the questions panel. The next session is next week, same time. Register if you haven't. And of course, we thank you for your time today. If you have ideas about follow-up sessions for this, as well as future deep dive webinars, we have been very happy to be putting these on for our users. So we would love to continue that tradition. Hope that everybody has a fantastic afternoon or rest of the morning, depending on what part of the world you're in. Take it easy. Nice job.